Good morning. I'm Brian Green from NeuronSphere. And this morning we're going to talk about semantic microservices. And why would you want a semantic microservice? And what if you wanted a whole factory of them? And how could you produce one? And what kind of attributes would they have? So we're going to go back, talk a little bit about the previous demo to kind of set the stage. We had some log files. We had big piles of JSON. And we used NeuronSphere and Mickey and some code generating tools to bring those in kind of the data lake layer, right? So those ended up as Parquet backed files. Now we want a more transactional place to store some information about hospitals and devices and the relationships between them, and those are going to change over time. And rather than just a database connection, the ability to query it, we really want some interactivity. We'd really like maybe an API, right? So let's talk a little bit about kind of app architecture a little bit. We'll draw the tiniest picture of that. So we have our user, and they're using some kind of application, some mobile or a web app or something, and that application is talking to some kind of compute, right? And then maybe that information is being stored in some kind of database. This looks like it's good size. Kind of the standard sized drawing. So we want to build this section such that we can support multiple kinds of applications, because maybe we don't want to just use a mobile application. Maybe somebody wants to use a Jupyter notebook. Maybe somebody wants to go build a web app against it using TypeScript, right? So we want a nice clean API surface here. This is pretty straightforward app architecture. What would we want in the ability to create these quickly, right? Like, don't we just need one? We see a real push towards domain-driven services. And I think if we're going to do data products and we want to think about surfacing the results of analytics, building APIs that allow us to go from that data lake layer back up through these services, right? And join the data from transactional services with the deeper data. I think that's where we're headed, right? So we want a service factory, and users, like we do a lot of interactivity with that analytical layer. But up top, we really want, CRUD. We want to create new entities and we want to list them, and we want all kinds of security. So let's talk about some other attributes we want. I have a little list here. It probably should be kind of execution agnostic. So where does the service run? Shouldn't be that big a deal. Let's talk a little bit about storage. I drew this picture of a database. For a long time, we persisted most everything in relational databases. And what an application architecture like this would usually mean is that we would be modeling something in third normal form here. We'd probably have some kind of class diagram here, and we'd be doing third normal form. We'd be talking about ORMs maybe, right? We can have a whole discussion about that. Over time, a couple of things have emerged. One, ORMs are challenging, and mapping objects onto relational databases is very useful, but it does run into some edges. The other is we've seen an explosion in new kinds of storage technology. So this thing that looks like a relational database might be Mongo, it might be Dynamo, it might be a graph database. There's lots more ways to store the data, and there's a bunch of interesting performance characteristics and query characteristics that you get out of those engines. But what it means is we're kind of at a loss, right? Like, we used to be able to do this very quickly, like build some classes, build some tables. It was very straightforward. Kind of everybody was trained on that. And with this explosion in storage, we kind of need a new kind of data modeling. And that's where we're going to talk about a semantic data model, right? So we want a semantic data model, and we don't want just relational storage. We want the ability to maybe use relational storage, and we'd like to get some of that kind of ORM-ish promise back, but we'd like to change the target. So instead of saying we want to do objects into a relational database, parenthetically third normal form, what we're really saying is we want to take a semantic model and have a polyglot storage layer that lets us put it into a relational engine, take advantage of that when we want to, put it in Dynamo, put it in a graph. And that should be more transparent, right? So we, in a true service framework, I think we would get this polyglot storage capability as well. So Alex is going to show us some of that when we get to a demo in a minute. Basic CRUD, right? So I mentioned creating entities and updating them, deleting them. So should we allow hard deletes or soft deletes? What about versioning? Do we keep versions of objects? How does that work? Should we be able to, you know, how easily can we configure those operations, right? So this kind of user or this group of user, so now we'll talk a little bit about security. This user group can only do this kind of action to this kind of entity, right? So a good service framework would contemplate security pretty deeply. That is covered well enough that we're going to do a completely different demo about where security fits into the service framework. Alex will touch on it very, very briefly. Probably should be easy to do local development. I'm a big fan of, you know, can I get it to run on my machine? Can I get an example working? So everything Alex demos today is all going to be in the local NeuronSphere. This is the local developer experience. And we'll do another demo and talk about how does that deploy to the NeuronSphere cloud. So it should be, you know, easy to do local development, local testing. We'll talk a little bit about traceable identifiers. So I've got all these objects in these services. We're going to talk about hospitals and devices. Universal identifiers becomes an interesting idea, right? How am I uniquely identifying them? Do they have primary keys? If I've got a bunch of services and objects floating around, how do I know which service is home for which one? Where did an object originate from? So Alex will touch a little bit on what we call the NID. So we've got this high-level architecture. I'm going to draw a bit more detailed picture to go with this. So we're going to say we want hospitals and devices, and we're going to model a relationship in between them. As a hospital has a device, is that right, Alex?
I think I did hospital owns a device.
Owns device, okay. Sorry, you're just going to have to catch the audio for this one. So we're going to model these basic objects, and how much of this stack, you know, should I be able to get out of modeling these objects? So similar to the previous demo where we said, look, let's model some tabular structures. We use tabular structures to model down in the database layer. When we're up at the information tier and the service tier, we're going to model in these nouns and relationships. So these are nouns, hospitals and devices. These are relationships. Nouns and relationships have attributes. So Alex will show you some of those. We want to walk this example. From this, really from this definition, we ought to be able to generate most of this application, right? Like most of this API stack ought to be generated once and then pretty configurable, right? So we ought to be able to change how hospitals are persisted. So our example in this case is going to generate, let's see, we're going to generate a TypeScript client. We're going to generate a Python client. We're going to generate the storage config for the storage engine. We're going to generate some SQL views so that we can easily view what's in the database. We're going to generate some documentation so that we can see this and have meaningful conversations about it without looking at JSON files. And then we're going to build all this, take this API, deploy it locally, and then we're going to run some tests. So we're going to test the API locally. And then finally, we've got this data now. So we've got some data in our relational database behind our microservice. And we've got our data. Remember, we had JSON data that flowed into Parquet files. We've got this sort of in this pseudo data lake over here. We're going to write a new dashboard, and we're going to write a query that joins across these two data sources to visualize this. So now we can come in here and edit our transactional data easily and add new attributes to do sorting and filtering, add new dimensional values here, and use that up against our analysis against our big data store. I think I covered most of it. Alex, you ready to go?
I'm ready to go.
All right, so we're going to switch over. I'm going to erase this while Alex gets started and redraw a picture, and I'll be taking some notes and things while he's doing his demo. So remember, we're going to start with a blank slate, right? We're going to do that's the one thing I wanted to talk about. We're going to do HMD repo create. We're going to create a new service. We're going to create a new place to put these. It's called a language pack. And we're going to build all this stuff. We're going to see this work.
All right. So, as Brian said, we're going to start with a blank slate. So I'm in the HMD home from last demo in the projects folder or HMD repo home. It's going to show we have all of the projects from last time, and now we're going to create a new one. And so we'll run HMD repo create. And it's going to give me a prompt to pick a category of project types. I'm going to choose the NeuronSphere core. And from here, we're going to choose the project type we want to create. And we're going to create a microservice with an associated language pack. You could separate them out, but for this demo, we're going to create them all in one project. So we'll click that. And now it's going to give me some prompts to render out the template. So we're going to give a short name. So we're going to call this hospital. So then it gives me a full project name. I'm just going to accept the default repo name and the description. We'll just say hospital microservice. Now it templated out a bunch of files and did a quick commit. And now we have a working Git repository, and you can see a lot of files got created. So we're going to CD into there real quick. I'm actually going to switch over to VS Code, and we're going to look at some of these files. So here we are. This is our new HMD MS Hospital microservice project. You can see we got our standard folders for a NeuronSphere compliant project. We have a docs folder. We have the metadata folder with a manifest. It's a somewhat larger manifest than last time that we looked at, but this gives us build commands to run in order. So we're going to run Mickey and then a Python tool and a Docker tool. And it also has some information that will be used to deploy locally. There's also a config local JSON that's going to be used to control, where we're connecting to a database and stuff. Locally, of course, that's used for the local one. We have source. We have a CDKTF, not really needed for the local demo. We have a Docker file and source Docker. And this is going to extend from our base microservice image, where most of the magic of creating those basic CRUD operations happen. And you're going to see we're going to copy in some folders and install the Python package that's in this project as well. So you see it created Python, it created an HMD MS Hospital module with an operations.py file in it. And right now, I'm going to scroll up, it's blank, but you'll see later in the demo, we're going to edit this file and add a custom operation. So we're going to add a custom endpoint beyond the basic CRUD operations that you get out of the box. And the most important one in here is the schemas, and this is where the language pack lives. So we have HMD Lang Hospital, and right now we have some demo schemas for car and wheel, but we're gonna delete those. And I'm gonna go grab the hospital and device and hospital owns device schemas that we have written, and I'm gonna pull them in here. So we'll take a look. Let's start with hospital. So as Brian said, we have nouns and relationship. Hospital is a noun. It has a number of attributes on it. Some of them are required. Some of them are business ID, which means it needs to be unique. So we have name, address, and a couple other things. I pulled some of these example attributes from the schema.org hospital noun. Anybody wants to go check it out there. We also have device, which will represent our robot from last time. Same thing, it has some attributes. It needs a name and a unique serial number. And finally, our relationship, hospital owns device. And as Brian said, attributes can exist on relationships as well. So we just have a singular one here, installation date. We could add more. So now we have our entities that we want to build we want to store in the service. And so if I switch back to the command line, I can run hmd Mickey build. And this is going to go fetch some configs and templates from our public GitHub and generate a bunch of clients and code for us. So if we switch back, you can see we now have OPA bundles. So we have a basic OPA Rego policy for the basic CRUD that can be deployed. We have, as Brian mentioned, the Postgres SQL views. So we have a full SQL file with the view for each entity, or a singular SQL file with all of the views in it if you just wanted to create all of them. So if you notice here, when we store in our relational database in the microservice, we store everything in one table entity. And actually, I can show that in a JSON column. And then these views just split it out so it's easier to view. Give me a second and I will show you the actual database. Let's see, is that big enough or should that be bigger?
I can live with that.
Okay, so right now, if we look at entity, this is where the nouns will be stored. You can see we have a JSON column. The ID or NID, as Brian mentioned earlier, this will be given the unique ID for each entity. Created update is deleted for soft deletes, and then name would be the fully qualified name of the entity. So if we were storing hospitals, it would be HMD Lang Hospital.hospital. And same thing with relationship. We have a content for store the attribute data, and just an additional from ID to represent the ref from property, the from side of the relationship, and a to ID and to name to represent the to side of the relationship. And if we go back, we can also see some docs got created. So we have a Pummel class diagram, a couple of documentation RSTs for that. And if I go to the index here, I can add the classes index. I can spell index. Save that. We can go and run Bartleby and see what documentation gets produced. There it is, HMD Bartleby. Let that run. So it's going to render all those RSTs into an HTML file and a PDF, as well as render the Pummel drawing into an actual, I think it's PNG or something, and put it in the PDF and the HTML. So that's what's going to take a little bit. While that's going, I'm going to actually switch back real quick. Forgot to show that also in the Python folder, we have a second module for the language pack. And this has classes based on those entities schemas that we created with, getters and setters, and it has the definition. It will enforce if you're missing required fields or whatever. So you can interact with these entities in Python as pure Python objects. And we also get a generated client for, helper methods that will persist these things to and from databases, either through a REST API or the database directly, or search for them. You can see we have upsert, delete, search. So all of our CRUD operations here in a generated client, which we'll use in a notebook here in a little bit. So if I go back, Bartleby should have finished. Yep. And we'll open PDF. And let's maximize that. So you can see some things got created. We have the hospital classes and the class diagram. So you can see we have our nice class diagram here generated from the Pummel, which was generated from Mickey using the schemas that we created earlier, as well as some basic descriptions and what the attributes are and stuff for the different entities. And we get all that by just creating a microservice project and running Mickey and then Bartleby. Now, we can also just run build. And build is going to run all those commands before. So it's going to run Mickey again. And it's going to run our Python tool, which is going to take and compile a requirements.txt and bundle up a Python package. And then it's going to build a Docker image for us. By default, the Docker tool can actually build both AMD and ARM images, or Intel 64, AMD 64, and ARM 64 images. I have it set with an environment variable to just build only the current architecture of my host machine. But if you wanted to build cross-platform images, you can. It's built into the tool.
So this will run on the M series?
Yes.
So I've checked off the Python client and object model, the storage config, the SQL views, documentation, the TypeScript client, how Mickey build creates all those artifacts. I think I've got some good notes here.
It's almost done.
So now we're building our local service, right?
Yep, we have a local Docker image that we can deploy to the local NeuronSphere, and you can actually it's set up to also be deployed as a AWS Lambda function as a Docker image. So I'm gonna now start up my local NeuronSphere. And we need to run this first because it has the Postgres database or Dynamo, whatever database you're going to connect to, a couple other things. It also includes a little proxy web server that acts sort of like API gateway and translates an HTTP request to the format that the Lambda function image requires. So right now we're not running our service. We've just got all of the other stuff running, and then we can run HMD neurons. If I can spell NeuronSphere run. You'll see coming up here.
And that runs, it works between, because you're in the context of that project, right?
Correct. Because I'm in the MS Hospital project, it knows, it grabs which, it builds the correct image name to run. So you can see we ran a database init to just create a database, create the user and password for the database and stuff, and then we're actually running the container image. So let's go interact with it, and let's go interact with it through a notebook. So thing I can do is I can do HMD repo add, and we are going to, we're going to choose a secondary project type to layer on top of our microservice with language pack project type. So we're going to choose analytics. I'm going to choose notebook analytics. It's remembered everything that I entered into the prompts before, so I'm just going to go through and get all the prompts. Now, I'm going to try and, create some things. Okay, let's go back to GitHub. We should see a notebooks folder, which I don't, and if we don't, that's okay. We'll just copy it in. Oh, that's because it was trying to do it in a branch, so we need to add some files and commit them. I forgot a step. I apologize. Then we will try that command again. There we go. So you can see it created in a branch. And now if I can find my mouse cursor, there we go. I can select this merge command. And let's see if it did it. It might have you permissions. Nope, we got notebooks now. So there was some old Mickey stuff that was under root that it didn't like, but we still were able to merge in the branch. And now we have a notebooks folder with an example notebook. And you can see it here. I'm actually going to copy over it. Right now, it just shows a print hello statement. So we're going to copy in some code so you don't have to see me type it all out.
So this is a notebook that's going to run in the local NeuronSphere. It's going to use the generated Python client to interact with the locally deployed service.
Correct.
Okay.
So we're going to go to Jupyter Lab that we saw last time. We're going to go into our work folder, and then we have HMDM as project or hospital. And we go to source, notebooks, and open up in our example notebooks. I'm going to clear out all the outputs real quick. So you can see here, we're installing, we won't do the -e, but we're installing from the HMD hospital source Python folder. So we're installing it directly into the notebook. Then we're going to do some imports of importing that generated client and the hospital, and then we'll go through and create some. So I'm going to run these. So it's installing it. Then we'll import and create a client. So we're going to use a base client of REST client. So we're going to interact through the created REST API right here. We'll call the proxy, and then we'll say we want to call the MS hospital service. So first we'll create a couple instances of the hospital noun. And we'll call it serialized so we can see the dictionary objects, and then we're going to loop through them and call upsert hospital, giving it that hospital instance. And then we'll hold on. I've had this happen before. Oh, I need to actually. Sometimes installing it directly into the kernel, it doesn't recognize all of it right away.
It's a demo gremlin.
It is a demo gremlin. They got me. Did we lose our schemas in the merge?
I think so. I think
so. The big demo gremlin got us. We'll just copy those back over. Here they are.
Aha.
There it goes. So you can see it name, address. We added an identifier. We can go see them in the database. So if I refresh this, you can see we got 2 records for the hospital now. We'll switch back, and now we'll do the same. We're just going to create one device, upsert it, and then view the search results again. There, created. And now we'll go through and sort of take the loop through the hospitals and relate it to that device, both of them to that device, just to see how creating a relationship works. So we'll give it the ref from, we'll give the hospital identifier, the device identifier, and it should create 2 relationships for us. Going. And I'm just only, should we only create one? Oh, that's right. We did create 2, but what this is doing is saying, give me all the relationships where this hospital is the from identifier. So we go look back at the database. You can go to relationship, and we can see the 2 relationships there with their own unique ID as well. Now, that's fine for kind of initial messing around with it or doing it, but it'd be kind of nice. That seems like an operation we're going to want to do over and over again. So it'd be kind of nice to have its own endpoint to just add a device to a hospital, something that we can just call with a payload. And give me a second. Something's loading, and I'll show. So we got insomnia here. There we go. A little bigger. So it'd be kind of nice if we had this endpoint to add device and give it a hospital identifier, and then in the put payload, give it an installation date and then the device data, and say, look up my unique serial number and either create a device if it doesn't exist or just create the relationship to the existing device. We can do that through that operations.py file that I showed earlier. So I'm first, before I forget, I'm going to go grab one of these hospital identifiers. And we're going to copy it here. So if I try and hit this now, actually, it's going to return with an error message that says that the operation doesn't exist. See, no operation found, because we haven't written it yet. So I can go back and we'll go, I've written the operation already. We'll go back to VS Code and we'll do this. Let's copy in some code here. Real quick, going through it, we have some imports, some helper functions. We import our client and a couple of entity classes. And then this setup function is going to be called when the service starts up, and we can use it to define functions and then decorate them with this service.operation. And this will say, add a REST path at this URL path, and this part of the URL is the hospital ID. I want to accept the put method, HTTP verb, and we're also going to give a JSON payload with it. And so, this will receive the Lambda event and a context. So what we're going to do, we're going to go through, get the arguments, get our first configured database client. We're going to grab the hospital NID from the URL, throw an exception if it's not there. Then we're going to build our Lang hospital client with the DB engine client. So instead of interacting with the REST API, this is going to interact directly with our Postgres database that we have set up. We'll go get the hospital based on the NID. If we can't find it, we throw an exception. Then we'll grab the device data from our JSON payload, throw an exception if it's missing. Then we'll deserialize that JSON data into a device instance. And then we're going to go through and using that same generated client, search for that device based on the serial number. So where serial number equals whatever you passed in. And if we find more than one, we're going to throw an error because serial numbers should be unique, we say in this instance. And then if we find exactly one, we're going to set the device identifier to whatever existing device we found's identifier. And then we're going to upsert that device. So if we've found an identifier, it'll update any data. If there is no identifier, if we didn't find one, it'll create it. And then we're going to go do that create. You're going to upsert that relationship again, this time also grabbing the installation date from the payload. So we'll see an attribute created here. And then we'll return the relationship data. So if I go back.
Did you save it?
Thank you, Brian. And I saved it. We'll run build again so we can rebuild the image, and then we'll restart it. We'll do run again as well.
So when we run HMD build, what it really does is reaches into that manifest file and looks at the subcommands to build.
Correct.
And oftentimes the first thing we do is run Mickey. We tend to do a lot of code generating as part of these projects. So Mickey is usually when you run HMD build, Mickey is the next thing that happens. Particularly when used in CI/CD, this is useful because it's the automatic first step of building your project is to run code generation and generate clean artifacts. And then this one just happens to run through, we know we want to generate a bunch of Python stuff. And so we want a Python build. And that, accepts a bunch of defaults in the Python tooling and adds a number of others, similar with the Docker build, right? So the Docker command is very straightforward, but there's a bunch of added options and flags and things that it's setting.
There it goes. All right. And now if we run the NeuronSphere run command again, it should restart our container and we can try and hit that endpoint again. So there it started up. Let's switch back to Insomnia and try calling this endpoint again. See there, now we have created a relationship with the installation date attribute on it. We can go, do it back here. You can see it added it here. So it appears our operation works. It'd be good practice to have integration tests for it. So I actually have those. We're gonna go in and drop a bunch of files the test files in our test folder. And so if we look at this robot file, what we're going to do is in our setup, we're going to clear out our database. So everything we've just done is going to go away. We're going to load a bunch of hospitals, a bunch of devices in our data folder here. So, we're going to load these devices, and these serial numbers correspond to the data in the data lake from the last episode or demo, and then a couple test hospitals that I just made up. And then once we've loaded those, we're going to a number of times associate a hospital to a device with a specific installation date. So this is going to go through, find our hospital, get its identifier, find our device so we have all of the data, and then call our add device endpoint with it, and then go and check that the device has one outgoing its relationship to a hospital, and that relationship has an identifier.
Cool.
So if we switch to our command line, figure this out, we should run HMD Bender, give it a context file so it knows how we've deployed it locally that exists in the test folder.
So these are the same integration tests that would run against this service if it was deployed in the cloud.
Correct.
And this is using Robot Framework, and our tool, the HMD NeuronSphere tool that's wrapped around it, is named Bender. And it also is setting a bunch of defaults and adding a bunch of things to the test case execution, and generally providing some coordination so that what happens in the test, the integration testing layer is well coordinated with the rest of the NeuronSphere artifacts. Look at that. We are running HMDMS Hospital.
Running that test suite, yep. It's going to go clear the database, add our hospitals, add our devices, and then call our endpoint a couple of times.
It is not a particularly noisy test. I think we're going to see another demo later this week that has a couple of fairly noisy tests. This one does a lot of work and then gives you some results.
If we want, we can try and see the entities coming in here. See, it looks like we've loaded our hospitals and our robots. And we've created one.
Yeah, I bet the rest of them are there by now.
If I'm hitting the refresh button wrong. Oh, it's probably searching, and yeah. There's the second one. So they're coming in.
All right, let's go see those results.
A couple more to do. But yeah, we'll show the Bender results as they show up. There it goes. So our test passed, and we got a nice little file here that does a nice summary of what happened in our test. So we've set up the test data, and it went through and says we've called that device with these parameters this many times, and they've all passed. And now, as we said, we can go to superset and relate the data in those Postgres views we showed earlier to the data that we ingested last demo. So we're taking all of the event data from the last demo and relating it to a device, and then traversing that relationship to a hospital. So we get a device ID, a hospital name, and this time we've added a couple geo coordinates, so we're splitting them out and doing a latitude and longitude. And if we use that as a data source, we can create a new dashboard, and we can show where those hospitals are. You see hospital data, similar charts. We can filter on hospitals now, and it should update all these charts.
I was drawing a picture of your cool federated query.
Oh, thank you.
As it wakes up.
As it wakes up, yeah.
There you go.
There we go. You know, it's just filtered on just that one, the hospital, the events for just that hospital, that device is in that hospital. And there we go.
Nice. Well, I think we managed to get through the entire demo.
Yeah.
So that was a lot. We started with a blank project, and we created an entire service. We created the entire storage layer, client so that we can interact with it, integration tests. I mean, obviously, there's a little bit of, sort of man behind the curtain pasting some of those files in. Oh, we will post all of the files used in this demo in one of their open source repositories in the NeuronSphere location. And we'll post that as a comment to this event a little bit later. All right. Thanks much.
Thank you.